That's it for forces and motion. This section is about waves, and the waves we're going to look at are seismic waves. Seismic waves belong to the same family of waves as sound and ultrasound. They're vibrations that are transmitted through matter. They travel as shock waves through the Earth. As you watch the next clip, make a note of the two different types of seismic waves and the different effect they have on buildings.
San Francisco is on the west coast of the United States. It lies at the intersection of two major tectonic plates, the Pacific and the North American. This is the San Andreas Fault, where there's a constant threat of a major earthquake. When a fault ruptures, usually many kilometers underground, a massive amount of strain energy is released in the form of seismic waves which shake the Earth. Seismic waves are vibrations in the underground rock. Primary or P waves are longitudinal. As they travel out from the earthquake focus, each segment of rock vibrates parallel to the direction of motion of the waves. Secondary or S waves are transverse. The segments of rock vibrate at right angles to the direction of motion. P and S waves cause very different effects at the ground surface. P waves from an underground earthquake tend to shake buildings in the vertical direction. This doesn't cause much damage because of the strong vertical pillars which support a building's weight.
Let me demonstrate the behavior of buildings by using this model. The normal loading on buildings is its own dead weight, which loads the building in the vertical direction. Most buildings have substantial strength in this direction. However, most do not have enough strength in the lateral direction.
S waves tend to shake buildings horizontally. Transverse waves like these cause most of the damage during an earthquake.
Horizontal input at the base of the structure, such as that caused by S waves, can greatly amplify the motion at the top of the structure.
Buildings can be made more rigid to withstand horizontal stresses. This is done using cross-bracing or by fitting a so-called shear wall.
As you can see, with the addition of the shear wall, the amplification from the base to the top is greatly reduced. During future earthquakes, this will help prevent people from being injured or killed.
So we saw that the two kinds of seismic waves are longitudinal P waves and transverse S waves. The longitudinal P waves move buildings up and down and don't cause much damage. The transverse S waves move buildings from side to side and do more damage. Buildings can be specially reinforced to protect them against the effect of transverse S waves. That's the end of the section on seismic waves.